Hey, Programming 12, we are back, and we're going to talk about walking in the direction that we're facing in our 3D environment. I'll run the program and show you what we're doing. So this is where we are right now. We have a 3D environment. It's a basic one. It's got a floor. It's we are facing directions, and we can use the mouse. It's a little bit derpy. We can use the mouse to kind of look around, right? I can look up and down. I got my mouse gets a little stuck because I haven't fixed that problem yet, and I can look all over the place. It's great. But I still am locked into the grid for moving, right? When I press W and S, I move backwards and forwards. And when I press A and D, I move side to side. It doesn't matter which way I'm looking. It's like I'm locked on this sort of grid. Here, let's face forward. See, I'm pressing W and S right now, moving backwards and forwards. If I turn to the corner, I still move along those grid lines, right? I'm locked into that. I can move diagonally, I suppose, but like it's not moving in the direction I'm facing. And anyone who's played a 3D first-person game, like that's supposed to be how it works, right? You're supposed to, when you press forward, you move where you're facing. You can steer yourself by rotating the mouse. That's got to be the way we do it too. It's actually really easy to do because we've already done the hard part. We've already done the trigonometry to figure out where to place our camera. So if we just move in that direction, if we just change our X and Z variables by the same kind of way we're changing our camera's focus point, then we'll accomplish exactly what we're doing. So basically, you just have to remember back to the trigonometry we did with the focus point. There you go. That's going to be our answer. So let's go take a look at that trigonometry. I'm going to scroll down. Here's our control camera function. And here's where we are changing the focus X, Y, Z variables. And so we discovered that focus X is going to change with cosine. Z changed with sine. We had some lovely, lovely pictures with a cow to help you. We did the Y with tangent. Now, we still haven't gotten into that too much about how that works, but we're going to focus on these ones today anyway, so let's just start there. So you can go back and watch the last video to understand where the trigonometry was happening, or ask me in class if you're not too sure. We can go over it again with maybe on the whiteboard where it's easier to draw the diagrams. So basically I want to take this and apply it to our keyboard controls as well. Right now when I press W, I just move in along the Z axis in a very specific way. Now I want to move in the direction I'm facing, right? In a direction along that angle that I'm pointing in, the left-right head angle. So it's going to be pretty straightforward. All I got to do is when I press W key, I'm no longer going to just move IZ, I'm going to move IX as well. IX equals IX plus something. And I'm going to make this plus now. So what do I add in here? I just add the same trigonometry. I'm going to basically look at the angle that I'm facing, and I'm going to do the trigonometry to isolate those components. So I'm mostly just going to copy and paste that same trigonometry that aims me in a particular direction, because that's also the direction I want to walk. So I'm going to add, the X component and the Z component. Now, there is still one change to make, and that is the 300. So 300 is based on where we want to put the focus point. And I chose 300 because 300 pixels puts that point at a nice location. Just it's nice and visible, but not too far away. That's not actually how much we want to move. That's a lot. That's a lot. There's no a little a lot. That's a lot. Moving 300 pixels every frame when we press the W key is going to make us zoom. So I'm going to bring this down to like 10, for example. So now I'm going to, this will get me the X component, and then times it by 10 to, because that's like kind of the length of our hypotenuse. So we're basically going to be moving at a speed of 10 pixels per frame. The sine gives us our Z component, and again, that sort of is our speed that we're going to move along. Let's run it and see what happens. Oh, I forgot a semicolon. So let's see if this works. All the trigonometry is exactly the same as the previous lesson, so ask me more questions about that if you're not too sure. Okay, here we go. So I'm moving around, and I'm facing the corner now. I'm going to press W, and sure enough, I move towards the corner. Let's go face forward. I move forward. My mouse ran out of room to move, but just to see, like, as I move, I'm just holding down W, and I'm moving my mouse, just kind of scrolling left to right, and you can see that it's like following my position. So I'm able to move like you would expect to in a 3D game. How about S key? So S key should move backwards along that same vector, right? So I basically just need to do the same thing here, but subtract instead of add. So I'm going to put in these braces because that only works if there's having no braces in an if statement only works if there's exactly one line that happens if the statement is true. I'll need braces to create a block of code from multiple lines to get executed. If that S key variable is true, I'm going to subtract instead. So now I'll move backwards along that vector. I'll just test it to make sure. It's always good to test, even if you're like, oh yeah, it's totally right, it's totally right, it's totally right. No, it's not totally right. Do check. Yeah, it works. It turns out it's great. I can steer going backwards. Good old trick in in these types of games. Yeah, what about the A and D key? So A and D should be like a strafe. Often games have a strafe where you can kind of walk sideways. Like the typical kind of like, this is my gun, first-person shooter. You strafe to like peek out the side of a corner, pew pew, and then you go back. You don't want to like rotate, walk to the corner, rotate, shoot, rotate, move back. No, you just press the strafe key and you walk sideways, shoot, walk back, that kind of thing. So how do we strafe? Well, it's pretty easy to do. You basically are going to use this exact same math, but you can just move at 90 degrees to the direction you're facing. And if you're moving left, it's going to be, I don't know if it's adding or subtracting. We'll have to do a little trial and error. I think it's adding 90 degrees, and if you move to the right, it would be subtracting 90 degrees. That's my hypothesis. Let's see if that's correct. So basically, the A key moves left. So my hypothesis is to get the 90-degree sort of vector to our current location, the orthogonal direction, if you speak math. We'll add 90 degrees. And, is left-right head angle is in radians, I believe. I'm pretty sure, yeah, I think we're just doing radians. Yeah. So we have to add 90 degrees. Well, you could say plus radians 90, if you like. 90 degrees in radians is pi divided by 2. So you can do pi divided by 2 as well. So there you go. That's like adding 90 degrees. I'll leave it to you to decide how you'd like to put that. So pi divided by 2 is 90 in radians. So let's see if that works. I'm going to press the A key and see if I go in an orthogonal direction, strafing to the side. So I'm facing this way, W and S move along this vector. Does A move me that way? I think so. That looks good to me. So I guess the adding 90 was correct. Yeah, I think that's going in the right way. So here's me pressing A. I'll face this way. I'll press A and I move along there. If I face this way, I move along there. Yeah, I think it's good. So my hypothesis was correct. To make the D key work, I need to strafe the other way. So I'll just subtract 90 degrees. And in radians, that's pi over 2. So basically the same, but subtracting. Subtract, subtract, subtract. And now I'll test that, see if that works. Probably will, but always good to test as you go, right? Avoids making mistakes down the road. All right, here we go. So I'm strafing to the right, to the left, to the right, going forward, going backwards. Oops, wrong key. There we go. Hey, I think it works pretty good. Doesn't that feel nice? Doesn't it feel cool that you've made sort of these keys that work the way you expect them to? And we still got a problem though. Look what happened. My mouse falls off the side. Once it leaves the screen, I no longer control the head direction, right? It falls off of the screen when it gets to the edge. That's not good. That's not how games work. So we have to fix that. That's what we're going to do in the next video. We're going to be importing something called the robot class, which is wild. Just to say that out loud, it sounds so cool. It's a library of code that's for Java specifically, but we can use it in processing that allows us to sort of automate user input things like keyboard presses or mouse clicks and that kind of thing. So what we'll do is we'll use it just to teleport the mouse if it gets to the edge of one side of the screen, I'm not sure if you can where my field of view is, but if the mouse goes off one side of the screen, it'll wrap around to the other side of the screen. So you could effectively keep scrolling, scrolling, scrolling forever. I know that's not exactly how Minecraft works. I know Minecraft somehow like centers the mouse. If you've ever like alt-tabbed out or like flipped over to another program while playing Minecraft, sometimes the mouse is still kind of locked in the center. So I think there's a way to do it that way. That would be really cool. I just haven't figured that out yet. So I'm going to do the thing where the mouse goes to the side of the screen. If it goes off the side of one side of the screen, it'll pop up on the other one. So you can just endlessly sort of scroll left and right, just keep spinning around. I think that'd be great. Okay, so just tune in there to our next video to find out how to use the robot class to accomplish that feat. Thanks so much, Programming 12.